Good morning. Here we are, class number 2. So as I'm always going to typically start class by pulling up our syllabus calendar. This is on the back page of your syllabus, so you have a copy of this, just so you can see where we're at for today. So if you remember last class, we did all of lesson 1 and we started lesson 2 where I did the demo part. Today we're going to finish lesson 2, which is the activities. Okay, so you're going to do the activities for lesson 2. They start on page 11 of your packet. So you turn to page 11. We're going to start with that. I'll be coming around to work with you as you need help and to learn all your names. And then we're going to move on to lesson 3 in a little bit. Okay. And I just want to point out that your first homeworks are due on Thursday, September 10th. For lessons 1, 2, and 3. So that's 3 assignments I'll do on Thursday. Okay. All right, so again, turn to page 11 in your packet. We're going to do the activities from the class that we started on Thursday of last week. Okay. We're talking about word problems, so here's some activities involving word problems, and I'll be coming around to discuss with you. So we're going to move on here to, actually, let's take 2 minutes to do the quick check. This is page 15. Quick check is material from the previous lesson. So this is actually from lesson 1. So take 2 minutes, do the quick check, solve that equation, and we'll make sure that everybody can do that before we move on. Okay, so when you're solving an equation, you have a goal to try to figure out what x is. You want to get that x by itself. Okay? You can do anything you want at any time as long as you do the same thing to both sides of your equation. Often, when there are parentheses, the first thing people want to do is get rid of the parentheses. It makes your life a little bit easier. So how would I get rid of these parentheses? What do I have to do? Distribute. So I'm going to distribute the -3. Like whenever you see a subtraction sign or a negative sign, think of it as glued to the number that comes after it. So this is a -3 that I'm going to distribute. So the 2x minus 1 over 4 doesn't change at all. -3 times 6 is -18. And -3 times -5x is positive 15x. And that equals 2x. So now I've gotten rid of my parentheses and I have a fraction. I would like to get rid of the fraction because it just will make everything so much easier if I don't have to deal with fractions. So look at all your denominators in this equation. We've got a 4 and the rest of them are 1s, right? So my common denominator of all of those is a 4. So I'm going to multiply both sides of the equation. That is every term on both sides by 4, by the common denominator. So when I distribute on the left, when I distribute my 4 to each term, 4 times a fraction with a 4 in the bottom, the 4's just cancel, right? Cancel, cancel. And you just have 2x minus 1. Then you distribute that 4 to the -18, and you get -72. Then you distribute that 4 to the 15x, and you get plus 60x. Equals 2x times 4 is 8x. All right, now on the left, I'm going to combine like terms. I have a 2x plus 60x. So those are like terms, they both have x's. And then I have like terms -1 and -72. When I combine my x's, 2x plus 60x is 62x. -1 minus 72 is -73. And that equals 8x. So now I'd like to have all my x's on one side, all my non-x's on the other side, right? So I could subtract 62x from both sides. So 62x minus 62x is 0x. Those go away. And I have -73 equals 8x minus 62x is negative 54x. To isolate this x, it has a coefficient of negative 54. This says negative 54 times x. To undo multiplication, I divide. Divide by negative 54. Okay, so the negative 54's cancel. On the right, I'm left with an x. And on the left, I have a negative over a negative, so the answer becomes positive 73 over 54, which they don't have any common factors, so that fraction can't be reduced. So you just circle that as your answer. Okay, if you're still having trouble with this, there's lots of practice in the homework. Use the Help Me Solve This in my math lab, and if you need even more practice than that, remember at the bottom of the My Math Lab, you can always click Try a Similar Problem. Right? So there's an unlimited number of problems for practice. All right, let's look at lesson number 3. Turn the page. So in this lesson, we're going to solve word problems again that involve linear equations, and we're going to graph lines using intercepts. We also learn how to identify dependent and independent variables, as well as how to write an equation for one variable in terms of another. So don't forget, if you answer a homework problem on my math lab and you think you have it right, but my math lab says it's wrong, send me an email right away. I can always check and give you credit manually, or tell you like, no, it's actually wrong, and maybe tell you what your mistake is if I can figure it out. Also, if you haven't signed up for my math lab yet, you should do that ASAP because your first homeworks are due Thursday. Don't forget, you can get a free trial for 2 weeks if you're not ready right now to purchase it. Do that as soon as you can. Okay, so a model is a mathematical description of a real-world situation. So suppose an individual works X hours at a salary of $15 per hour. We're going to fill in this table of values showing how much a person makes, their wages, earned for the number of hours they work, X. So if you make $15 per hour and you work 0 hours, how much money do you make? $0, right? If you work 4 hours, how much money do you make? $60, right? Yeah, you multiply $15 an hour times 4 hours and you get $60. What if you work 6 hours? How much do you make? 90. 6 times 15 is 90. And what if you work 10 hours? $150. Good. All right, so we can think of these as points, right? So I have 0, 0. 0 hours, $0. 4 hours, $60. Think of that as a point. And 6 hours, $90. And 10 hours, $150. So I have 4 points that I can plot here. I'm going to plot them all on this grid that I've given you. The x-axis is going to be hours worked. And the y-axis is going to be wages in dollars. So I've got 0, 0. I think that's like right here. 460. 6, 80, that's 100, some 90s in between there. 690 and 10, 150. Looks like it's right there. They should all fall in a line. It's hard for me to read these numbers. It's 20, 40, 60, 80, 100. So 0, 0 is here. Here. So it's supposed to be 460. That's why I put it on 80. 460. Yeah, now they look like they're in a line. So if I connect them with a line, there we go. All right, so I would like to write an equation for W in terms of X. So that means I want to write an equation that has the form W some stuff with X's in it. W equals some stuff with X's in it. So I want a W equals. So W stands for wages. How do we calculate wages if you know hours worked? $15 times the number of hours you work. So it's going to be $15 times X. So we're letting X be the number of hours you work. Right? And we knew that from up here in the table. X is the number of hours worked. W is wages. For every increase of 1 hour, how much more do you earn? $15. $15. Good. And does this hourly rate change or stay constant? Constant, right? Always you get another $15. Right? Each hour, another $15. We're assuming there aren't going to be any wrinkles like time and a half or double time, things like that. Just flat hourly wage. Okay, I think we got a little typo here. For each additional hour worked, there is always an increase of $15. Right. I think we changed it to 15 to more accurately represent wages since minimum wage went up. Yes, or I could have written half hour, yeah. But for each hour, it's $15. So this is an example of a constant rate of change. The constant rate of change between two variables is what distinguishes a linear model from other types of models. That's why our picture came out like a line, right? Because every time you go over by 1, your wage goes up by the same amount, goes up by $15. So that's what makes that look like a line. Not all equations, not all models are linear. So we've got this graph down here. It's the equation y equals x squared. It's not a line. The rate of change is not constant, right? So here, when I go from 0 to 1, my y changes by 1. And then when I go from 1 to 2, my y changes by more, right? The jump in the y's gets bigger and bigger, right? So that would be like, if the first hour you work, you make $15, and then the second hour you work, you make $30, like if your salary got higher the number of hours you worked. But it typically doesn't, right? Yeah, that would be nice, but it's not typical. All right, since our wages depend on the number of hours we work, we call W the dependent variable. It depends on some other number, right? And X, the number of hours you work, we call the independent variable. Okay. If it helps you remember which variable is dependent and which is independent, think of Johnny Depp on an island by himself in Pirates of the Caribbean. Thus, the dependent variable, Depp for Johnny Depp, the dependent variable, is the one by itself in the equation. So in the case of W equals 15x, right? W is the variable that's by itself. Johnny Depp, alone on an island, dependent variable. So here, wages is dependent. Okay, of these two equations, where we have R equals T over 121 and T equals 121 times R, which one expresses T in terms of R? A T equals 1, yeah. T in terms of means the equation should look like T equals some stuff with R's in it. So that is the one, T written in terms of R. Okay. Now, looking at that equation, T equals 121R, which variable is by itself? T. T is by itself on an island with Johnny Depp, right? So in that equation, T equals 121R, T is the dependent variable. It depends on the value of r. Right? So r is called what variable? The independent variable. All right, so before, in our previous example, we graphed a line by just plotting a bunch of points. I'm going to graph a line again, right? We're going to graph this thing together. But we're going to pick we only need 2 points to graph a line. Any 2 points will determine a line. And I'm going to pick the easiest 2 points I can think of. Okay. So for me, the easiest points are if you make either x0 or y0. Okay. So in the first row of this table, we made x0. In the equation 3x plus 2y equals 12, if you make that x a 0 and solve for y, what do you get? 6. So we put a 6 there. Yeah. And then in the next row, I made the y a 0. So in 3x plus 2y, I'm going to make that y a 0. Solve for the x, what do you get? 4. Yeah. So I'm going to put a 4 over here. So these are called my intercepts, right? I've got 0, 6, and 4, 0. If I plot them, I've got 0, 6. That's my vertical intercept, also called the y-intercept. Right? And then I plot 4, 0. That's right here on the x-axis. It's called an x-intercept, or the horizontal intercept if your variable is like not x, but t or whatever. Sometimes it's called the horizontal intercept. So then we can connect those with a straight line, and we've got it graphed. So this is the quickest way to graph lines if they have this form ax plus by equals c. It works for all forms. You can always graph a line using its intercepts. It's called the intercept method of graphing a line. Okay. Since the point 0, 6 has an x coordinate of 0, it's on the y-axis. We call it the y-intercept. And 4, 0 has a y coordinate of 0, which means it's on the x-axis. We call it the x-intercept. Okay, all the demos are typically followed by an answer key, but we just filled it all in together, so you don't have to worry about this unless you miss class and you're doing it by yourself. After that answer key comes activities. So for the remainder of today's class, 35 minutes, you're going to work through the activities for lesson 3 that start on page 19.